All right, today we're going to be doing a lot of similar to last time. The vocabulary is basically the same. Okay, so you really need to learn what alternate interior angles are, same side interior angles, alternate exterior, corresponding. You really need to know those terms. Okay, and where the angles are located. So, one analyzes the diagram to see if line L is parallel to M. His teacher asks if there's enough information to say whether the lines are parallel. One says yes, they are. He says that since 2 and 3 are alternate interior angles, that makes these lines parallel. Do you believe Juan? Do you believe him? I believe him because he's right. Okay. Now, since 2 and 3 are alternate interior angles, that makes the lines parallel to each other. He also says, well, 1 and 4 are what types of angles? Corresponding. So if 1 and 4 are corresponding, that makes the lines parallel as well. And his teacher said, good job, Juan, because you are correct. Then the teacher asks, well, we have two lines that are not parallel. Is this angle 120 degrees as well? Can it be 120 degrees? Just because it's obtuse doesn't mean that it has to be 120. And the answer is no. This angle cannot be 120 degrees. There's no way it can be 120 degrees. If the lines are parallel, then it can be 120. But if it's not parallel, see how if it's parallel, it's a 120. So since it's not parallel, since this line is down further that way, it has to be what? Greater than or less than 120? Greater than 120. It has to be an angle greater than 120. Okay. So I'm going to fly through this next stuff really quick because we just saw it from up above with 1. Okay. Now, you'll see the magic word converse here, and you'll use converse when you have the proofs on today's exercises. Okay. If we know that corresponding angles are congruent, then the lines are parallel. If we're proving lines parallel at the end, then we use the converse of corresponding angles. If we start with parallel lines, then we say the corresponding angles are congruent. But if we start with angles that are congruent, that are corresponding, and we're proving lines parallel, that's when we use the converse. So we use the converse when we're proving lines parallel. So here's corresponding angles congruent. That makes the lines parallel. If alternate interior angles are congruent, that makes the lines parallel by the converse of alternate interior angles. So if we had vocab, this would be a vocab word, but we don't have vocab this chapter because this is just a minor thing. A flow proof uses arrows to show logical connections. So it's just another way of presenting a proof. Instead of 2 columns, they use diagrams and arrows, okay? Where the reason is right below the statement. So we are given that angle 1 is congruent to angle 2 up here, okay? We're also can figure out that angle 1 is congruent to angle 3 because they're vertical angles. Now, what can I say about 3 and 2? Well, those are what types of angles? Corresponding angles. And since 1 is congruent to 2 and 1 is congruent to 3, we know 2 is congruent to 3 by the transitive property. Also substitution, but in today's exercises on the proof that you'll do in your homework today, it'll be transitive property because if 1 equals that and it also equals that, then these two are equal by the transitive property. So using 2 is congruent to 3, in the end I could say that L is parallel to M by the converse of the congruent corresponding angles theorem. Okay? Because when you prove at the end that they're parallel, it's the converse. So these are same side interior angles. If same side interior angles are supplementary, that makes these two lines parallel by the converse of same side interior angles. And if alternate exterior angles are congruent, that makes these two lines parallel by the converse of alternate exterior angles. All right, so why can we say that M and M are parallel? What types of angles are 3 and 7? Corresponding, so you'd use the converse of corresponding angles. What types of angles are 3 and 6? Alternate interior. So we use the converse of alternate interior angles. Okay? Now, this little theorem here says if these two are parallel to each other and these two are parallel to each other, that makes these two parallel to each other. Okay? By the transitive property. If B is parallel to C and A is parallel to C, then A must be parallel to B. Similar to that, if A and C are perpendicular and B and C are perpendicular, that makes A and C, A and B parallel to each other. Okay? Because if they're both perpendicular to the same line, then they're parallel to each other. So, can Bailey say that V is parallel to W if we have A down here as a transversal? Is V and W, are they parallel?
Yes.
Yes, because they're both perpendicular to A. If they're both perpendicular to the same transversal, then they're parallel to each other. Okay? So, the converses. So, corresponding angles, if they're congruent, then the lines are parallel. Alternate interior angles are congruent, then the lines are parallel. Alternate exterior angles are congruent, lines are parallel. Same side interior angles are congruent, lines are parallel. Okay? So that covers your first assignment. You have 14 problems and about 14 minutes to work on them. So let's work on those. After lunch, we'll do a second assignment.